Hello, my name is Willow, and today I'll be discussing the topic of developmental networks when it comes to gene regulation and the expression of certain phenotypes in an organism. I'm going to use an example pathway I created to help explain this concept, and we will see what happens to the final product when different genes in the pathway get mutated. I'll be using the analogy of the TV show Avatar: The Last Airbender, which I'm sure a lot of young adults like me can relate to. The different characters represent different genes in the pathway, and they can influence the other genes around them. An arrow between two genes means that one gene activates the other, and a T-bar between two genes means that one gene inhibits the other. When we look at the pathway I drew out, it can be interpreted as such. If the Zuko gene is able to get transcribed, it can inhibit the Azula gene, which means the Azula gene is not able to inhibit the Katara gene, so the Katara gene can get transcribed and can activate the Aang gene, and the Aang gene can inhibit the Fire Lord, thus defeating him. We can then look at examples of when there are different mutations in our pathway and see how that will affect our ending phenotypic expression or result. So for example, if there was a mutation in the Azula gene, we would start at her in the pathway. If she is mutated, she cannot get transcribed, so she is not able to inhibit Katara, which means Katara is able to activate Aang. Aang is able to inhibit the Fire Lord, thus defeating him. We can then look at the example of if the Katara gene gets mutated. If that's the case, you start with her in the pathway. If she's mutated, she can't get transcribed, which means she cannot activate Aang, and Aang is not able to inhibit the Fire Lord, and so in this case, the Fire Lord wins or gets expressed. We can also see what happens if there are two mutations that occur in the pathway. So if the Zuko and Katara genes get mutated, normally you can look at the more upstream one, but I'll show you both in this case just so you can see how you can work through it that way. So if the Zuko gene is mutated, he cannot inhibit Azula, which means Azula is able to inhibit Katara, but Katara is also mutated, so she cannot activate Aang and cannot inhibit the Fire Lord. So again, the Fire Lord would win or be expressed. And then that last example would be if the Zuko and Azula genes were mutated. In this case, I'll start with the more upstream one. If Azula is mutated, she cannot inhibit Katara, which means Katara can activate Aang, Aang can inhibit the Fire Lord, and he will be defeated. And so an example like this shows how having different developmental pathways and different genes in the pathway can sometimes lead to different phenotypic expressions. In these two cases, it ended up with the same phenotypic result as our original pathway, but these two mutations resulted in the Fire Lord not being inhibited and him winning or being expressed. This shows an example of how you can work through a developmental network to find out what the ending expression will be and how the genes influence one another.